Being a Blender user, you've probably heard about DaVinci Resolve and its powerful color grading toolset. And indeed, Resolve is a super hot thing right now. It's being used by the industry professionals, but also by hobbyist creators, especially given that it has an absolutely functional free version. Maybe you've wanted for some time already to get your feet wet with Resolve and incorporate it into your 3D animation workflow, starting with Blender, then processing your stuff in Resolve, but you just don't know where to start, and there is so much to figure out indeed. What format to use for exporting rendered sequences, and what does it have to do with color management in Blender, and how the hell to even get the Blender footage look correctly in Resolve, because maybe you've tried to import the 32-bit XRs in there and it looked awful. That's why we made this video and this entire course, to guide you through that. A bit of a warning though, this subject can be really hard to navigate, as there are so many technical terms and concepts to wrap our heads around. It's a bit like math or coding videos, so if you feel a natural frustration, just know that it's completely normal and it will click eventually. Feel free to approach it at your own pace, I guess. The first stop, Blender. When choosing what format to use for exporting the sequences out of Blender, the key decision is how to preserve the sweet dynamic range that Blender gives us. To be able to adjust the exposure in post, just like we do it in Blender. To be able to use the sweet view transforms like AGX or Filmic, or something similar, just like we do it in Blender. In other words, how to maintain the Blender-like color management pipeline in Resolve. Unfortunately, the deliverable file formats like PNG or FFmpeg won't cut it from that perspective. When using such formats, the data gets crammed into the display container, and while it may look okay when we preview it in Resolve, in fact, it would look just like the viewport in Blender looks. When we try to reduce the exposure or something, we notice that it simply won't work. The sweet, wide luminosity range got lost along the way when saving in PNG or whatever, and that is of course super limiting and just a bummer when having to edit the footage in a meaningful way in Resolve. With the deliverable formats used for editing, it's super easy to clip or oversaturate the colors and do all kind of unpleasant stuff. Then of course we have the OpenEXR format on the other hand, which helps to preserve all the data generated by Cycles or Eevee. And that, if processed right, offers a much more versatile container for any kind of color grading and post-processing work. Meaning that the raw data is saved in full, and we can tweak the exposure in post. And the way that the OpenEXR format works is that, drawing the analogy from photography, imagine if nothing was ever clipped in a photo. Imagine an infinite range saved in a raw format. Or let's put it like this, the deliverable formats like PNGs are bound to the display range of 0 to 1, where 1 is the brightest value beyond which no information exists, while the intermediate formats like EXRs are unbound. So in post you're just pulling data from this infinite container to settle the final exposure to be shown to the viewer. The benefits of the unbound image data aren't limited to flexible exposure. When working with OpenEXR, you are free to choose how colors in general will appear to the viewer. That's called display transform, and it's like choosing the chemicals that will be used for processing a raw film. The chemicals of the DaVinci Stone mapping are very different from the chemicals of AGX or Filmic or the custom display transforms. More about these later. In order to export our footage in the OpenEXR format, all we have to do is go to the output settings and choose the OpenEXR file format, the RGB colors, and then it can be a full floating point 32-bit format or a half version of it, a 16-bit XR, which is usually more than enough for storing the beauty passes. To avoid any confusion, a 16-bit XR is fundamentally no different from a 32-bit one. It may look like we've changed the format, but in reality it's just slightly less precision, which practically doesn't matter if you're gonna use it as video and not displacement or something technical. Finally, there are very efficient codecs that we can choose from, ranging from lossless to lossy, like GWAA, which is actually much more efficient than PNG in terms of compression. To double down on that point, when stored in half-float precision with DWAA codec applied, an average EXR file ends up tinier than a PNG, while holding a wider range of colors. Paradoxically, it's also faster to write and read, and its alpha handling doesn't actually suck. Why isn't OpenEXR used more often instead of PNG then, if it's just better? Well, apart from simple awareness and a default PNG output is the lack of simple previewing of EXRs within Windows Explorer. It can be really confusing, but you cannot just simply preview an OpenEXR file. Funny enough, you would need an external viewer like XNView to be able to open EXR files in Windows. Or better yet, something like DJV, a free tool for previewing the EXR image sequences. The thing is, you would still need to point it out to the correct display transform. In DJV we can go Image Color Space Settings, and then hit plus to add the OpenColor IO configuration file. Sadly, it doesn't support the current version of Blender, but if you have Blender 3.0 somewhere, you can hook it up to the Blender 3.0 configuration file. It's called config.ocio. Then we can just select Linear within the image settings and Filmic within the display settings, and that would be the Filmic view transform from Blender applied to the EXR footage. So that's not bad, but we can preview it in Resolve anyway, so let's move on there. Oh, an important note, Resolve is quite sensitive to the file's order, so if you haven't skipped frames or something and everything is in numerical order, you can just drag this sequence into Resolve and it will interpret it just fine. If there are some discrepancies in the file's naming, like 01, 03, 05, clearly some skipped frames involved, then at least in Windows we can select the last file, shift-click the first one, F2 to rename, give it some name, and that will put it in order. Then in Resolve we can just open the Edit tab, and then Media Pool, and I have a few sequences already imported, but basically all we have to do is open the folder with the files that we have just rendered and drag it onto the timeline. And here the new sequence appeared. Hopefully it is recognized as a sequence, meaning that we did everything right. I will delete it though, and this one as well, and use the one that I have already imported, this fire.exr sequence. If it plays too slow or too fast, make sure to right-click the sequence and go Clip Attributes and check the video frame rate, which should be 24 frames per second in this case. Alright, at least it plays. Now let's drag the rest of the files onto the timeline, and this one as well. Okay, I'm sure you noticed that the preview looks totally wrong, not like it looked in Blender. What is going on here? That is incidentally how it would look in Blender if we went to the View Transform menu and selected Raw, meaning no display transform applied at all. So that's how the linear EXR footage looks without the View Transform applied. But obviously in Blender we have amazing view transforms like Filmic, AGX and whatnot, which work amazingly under different exposure conditions. More about that later. To set the color management in Resolve, we can go Project Settings, or press this cog icon, and then go Color Management and try to set it up from here, from within the Color Science menu, by setting all up manually, like all the inputs and outputs, but actually there's arguably an easier way to do that, or at least the way that will make it easier to understand the color management workflow. In this tutorial, instead of setting it up in the project settings, I'm gonna show you how to do it using nodes in the color tab, so we don't have to set anything here, just to be clear. So I'm leaving it at the default values with the color science set to DaVinci YRGB, which is important, otherwise chances are that the method I'm gonna show you won't work correctly. The only thing I'll tweak in the project settings is the image scaling resize filter. I'll change it from sharper to bicubic or bilinear. If we don't do it, scaling our EXRs would produce horrible artifacts. Well, what do we mean when we say horrible? See this kind of a blight near the high contrast edges? This type of horror, that is. Alright, so let's set up the color management pipeline manually from within the color tab. Here we've got our corrector node. We just need to open the effects tab if it was closed to begin with, then select clips that we want to adjust, like for example this clip with the fire, and find the color space transform effect. Here it is, and drop it onto this free node. I will call this node CST, meaning color space transform. Now basically what I'm going to show you is probably the quickest way to prepare the EXR footage to be viewed correctly in DaVinci Resolve using just the built-in tools. It won't be the most robust way to do it, just something to get a nice result really quickly. And by nice, I mean something that resembles AGX or Filmic, roughly in that ballpark, but using just the built-in Resolve tools available for free. The color space transform effect we've just added. All of that just to get you hooked, I guess, because in the more advanced videos from this freemium series we will explore how to change the actual colors of your EXR source footage, for color grading in other words. But first things first. Alright, input color space should be Rec 709, input gamma linear, as it's what EXRs use. And actually it's worth mentioning that as long as you export EXRs from Blender, no matter what was set in the view transform, in the color management, basically this full menu including exposure and gamma, it won't matter. It will always be encoded as linear Rec 709. It is just worth memorizing. Then the output color space can be Rec 709 and output gamma as RGB if we target the same output as in Blender, the same type of display. Well, arguably, if you want to be on a safer side, the gamma can also be a pure power function of 2.2 or 2.4. That may lead to shadows having a slightly lifted look on some displays, and there's no way to tell which monitor a user will have anyway, but some colorists argue that it's still better than having the shadows crushed on certain monitors when using the piecewise sRGB function. I know that may sound confusing, the difference between the sRGB and gamma 2.2 and 2.4 output. We throw around many technical terms without really explaining it, but I promise you we'll get to that in the next video from this series. For now, let's just set the output gamma to sRGB and leave the rest of the settings like that. Just pointing out that these extra OOTF checkboxes at the bottom are switched off for now. And these are the settings so far, feel free to copy them. Okay, we have some other things to do now. We've just instructed Resolve how to interpret our linear Rec 709 for display using this menu, but here we have one more menu to tackle, which is called Tone Mapping and is set to DaVinci by default. Actually, it doesn't do much in the way it's set up right now, so we can switch it off temporarily by setting it to none. Now, what is tone mapping and why do we even need it? Haven't we just instructed Resolve how to interpret our linear Rec 709 EXR correctly? By this thing? Well, yes and no. These inputs and outputs have defined the basic display transform, but in Resolve, to make it look good, you'd need to also play with the tone mapping part. It's just the way this effect is broken down into few subsections in Resolve, compared to Blender. In Blender though, the view transform, like Filmic, encompasses both the display transform and the tone mapping part on top. In fact, if we wanted to remove the magic part, we would have to switch to standard. What is called tone mapping in Resolve would be switched off, and we would have like horrible highlights, we will lose all the film-like tone mapping qualities, and Blender would just naively plot all the HDR values to display, and that's it. To reiterate, the problem with not having a proper tone mapping in either Blender or Resolve is that without it, the part of the dynamic range, specifically the highlights and the saturated parts, will end up outside the visible range after display conversion. That would be very sad indeed. I hope it makes sense, because different software throw different technical terms at us, so it becomes rather confusing. Generally, the terms like tone mapping, display rendering transform, or DRT, or view transform all mean a similar thing, a process of converting one color space to another. Then some software, like Resolve, also singles out the magic part, calling it tone mapping and making it a separate submenu that is meant to handle highlights and saturation and all that stuff. Let's put it like that. If any of this doesn't click immediately, or even doesn't make sense at all, it is actually normal to be confused about color management. We're throwing in lots of concepts and terms, like sRGB, linear, whatnot. Feel free to breathe out and rewatch any sections if you like, and I promise it will eventually make sense. cueing the relaxing murmuration of birds. So in Blender we have a very sophisticated, very cool view transforms, with the tone mapping part being included into them, like Filmic and AGX, which handle highlights and saturation gracefully. Now, how do you set it up like that in Resolve? Well, that's what I'm gonna show in a second. Even though later on we'll have a look at various view transform methods, including AGX, Filmic and more, for now let's have a look at the DaVinci's own tone mapping. If we turn it on and then tick the Use Custom Max Input checkbox and increase the max input nits, we will notice something very similar to Filmic and AGX in how the highlights got rolled off. It kind of makes sense. Nits are used to measure the brightness, so by increasing this limit we allow the higher intensity light to reach the screen, essentially. Hence the graceful roll-off. Okay, I usually play it safe and raise that ceiling all the way to 10K, to the end, even though it appears to do very little here. What does it mean? There's no more nuclear yellow picking it through, and it kind of made it already look like it could be a decent alternative to Filmic, even though at closer inspection Filmic still seems to preserve slightly more detail in the hot areas, by somewhat desaturating them in a very cool way. That being said, the DaVinci's display transform doesn't look that bad. There will be time when we talk precisely about these things, display transforms, in another video. For now though, let's tap ourselves on the shoulder for setting up a decent one in Resolve. And actually having display transforms set up means that we can also have a proper exposure control. How cool is that actually, being able to adjust the exposure in post? Cinematographers would give their left arm just to have that feature alone. Let me show you how. I will right-click and add one more corrector node and place it before the color space transform. This will be our exposure. Now, dragging the point of the RGB curve to the left is the same as increasing the gain or increasing the exposure, and dragging it down like that is decreasing the gain or exposure. What is important about this configuration of nodes and why it even works is the fact that we are changing the gain, which is actually a linear multiplication operation in the linear Rec 709 space. See? Before it gets crammed into your monitor color space. What happens before that still happens in the potentially infinite light range, and that's why it works. It's really fortunate for us that Resolve actually supports the linear light values. It's kind of a luxury given how many apps totally drop the ball when it comes to linear workflows. Ooh, let's not get into that. So we have the exposure control now. To have it tested under different conditions, I'm gonna enable this clip and then middle mouse button click on the first one to sample its color management settings, and I'm gonna do it for this one as well. Pretty cool, pretty cool. You know, if the source footage is fairly restrained in terms of colors, the DaVinci's DRT is actually doing well. Just for comparison, here's how it would look in Blender with Filmic. A close call. As for me, that shows that we've got it working in Resolve. Filmic's not perfect, don't get me wrong, but it's a very good view transform anyway. Getting a pretty similar rendition of colors in Resolve using its built-in tools can be considered a win, I think. So you can see, despite the differences in software, this panel in Blender and this panel in Resolve can produce pretty similar looking results. Then, of course, there are some extra bells and whistles in Resolve, like the adaptation slider, which seems to be yet another way to influence the exposure. And then there's this gamut mapping thing, which can be set to saturation compression, and that would limit the amount of colorfulness that the display rendering transform can output. That could be useful for handling the extremely saturated sources, for instance. There's a chance though that if you're just poking around the color space transforms for the first time, you won't need to dig that deep though. And finally, there are these extra OOTF or Opto-Optical Transfer Function checkboxes, forward and inverse, at the bottom of this panel. We haven't touched upon that just yet. Let me just say that the forward OOTF pretty much always needs to be checked when it comes to display transform, but as we are just trying to get a quick preview of our EXRs without really diving deep into the meaning of all the settings, we can allow ourselves to ignore these advanced settings for the time being, and return to that later in the more advanced videos. Alright, this was our first look at how color management panel in Blender and color space transform effect in Resolve work, how both of these systems manage the adventures of the EXR data so it turns into a beautiful image with the help of the display transform and a little bit of tone mapping, aka extra magic. Whew. So, before I snap back into urging you to enter that rabbit hole and get the full 4-hour course on color management in Resolve on our Gumroad, for free, by the way, or using a good old pay-what-you-want monetizing model, let me show you a quick recap of the process and give you the recipe for recreating the Filmic and AGX levels of contrast, all using that single-node technique in Resolve. Not the true Filmic and AGX though, for that we'll have a separate video. Just something in that ballpark. I'll go really quickly this time. Here's an EXR sequence freshly exported from Blender. There's no display transform just yet, so the preview shows the incorrect colors. To fix it, enter the Color tab, make sure that the Effects tab is also open, and search for the Color Space Transform effect. And just throw it onto the correct node, the one that is there by default. Then set the input color space to Rec 709, I'm doing it by typing the first letters, and the input gamma to linear. The output color space should also be Rec 709, and the output gamma can be sRGB. And if you don't check these extra OOTF checkboxes at the bottom of this panel, it will look almost like Filmic in Blender in terms of the overall contrast. Although technically it should always be on when doing display transform, I mean the forward OOTF, but never mind. Okay, set the tone mapping to DaVinci and then crank up the max nits all the way to 10K or something like that. Feel free to copy these settings. It will make it look almost like Filmic in terms of rendering these EXR's data to screen. And it's pretty close, as you can see. The difference between Filmic and the DaVinci's own DRT is fairly minimal, at least in these examples. Then to recreate the AGX levels of contrast, kind of, not the highlights, desaturation of course and all of that, but just the overall contrast, set the output gamma to gamma 2.4 instead and turn on Apply Forward OOTF checkbox this time. Let's play this Trust Me Bro game. I promise I'll explain what these settings mean in the next video. So anyway, these settings should make it look a bit more similar to AGX as far as the overall contrast goes. Then if you need the exposure slider, just like in Blender, add one more corrector node before the CST, or color space transform, and move the top end of the curve left and right, or up and down to increase or decrease the exposure, or the amount of light that reaches the virtual camera sensor. Pretty cool, that was our first look at how to open and process the OpenEXR sequences from Blender in the free version of DaVinci Resolve, with the help of the color space transform node. And as you can see, in this basic form, it requires just half a minute to set it all up. Definitely a good start, and I believe a good first look into the subject. This one-node approach has certain disadvantages though when it comes to really wildly colorful stuff, like the synthetic EXR color sweep. Using just one node as display transform makes the extremely saturated colors collapse into the primary 6, also called Hateful 6 in Troy Sobotka's terminology. Red piece yellow, nuclear cyan, extreme magenta, and so on. That isn't some defect of the DaVinci's tone mapping, it just requires some extra steps that we didn't take in this video. And of course, if you are watching this video and this series of videos, you want to know how to make the next step and actually start changing the colors of the source EXRs in a creative way. Not just previewing it correctly, but doing something with it. I bet you also want to know how to match the amazing AGX and Filmic looks in Resolve. Not just approximate with the built-in tools, but use the real deal. I know that for a fact because that's the most frequently asked question. So for all of that, I actually recommend you checking out our pro color grading video and the entire course available on Gumroad. There is an adventure waiting for you, and not on the other side of the paywall, but because there is no paywall this time, but simply at the push of a button. Although, even though it is available for free, I would greatly appreciate if you supported the course authors by donating any amount that feels comfortable to you. It starts at just $0 and then goes up in increments until the shrimp's the limit. Just pick your emoji, I guess, from this list.